Hello, and welcome to Prototype and See, the podcast for designers, engineers, and innovators all about the product development journey. My name's James Murphy, co-founder of HLH, one of the world's leading manufacturers of prototypes and bespoke production parts. And in this series, we'll be sitting down with some of the world's most innovative companies to discuss and find out how they go about bringing new products to life. And today, we're very happy to have with us Josh Shires from Fyous, a very innovative new manufacturing technology company based in Sheffield, and you guys are responsible for a completely new, as I understand it, way of making products called PolyMorphic Moulding. Yeah. So welcome, Josh. How are you doing?
Thank you, James. Thank you. Yeah. That's good. It's good to see you again as well.
Yeah. We've met.
We've come full circle.
Indeed. Yeah. So, I mean, can you just introduce yourself for us first, and then I guess we'll move on to the company after that.
Yeah, sure. Yeah. So, Josh Shires. Originally started with my first business, mouse products, about over 10 years ago now. But I've been making products, inventing things like for the last 15 years, trying to take ideas to market. But yeah, started with mouse products. We invented a phone case that stored your headphones, which subsequently failed. Right. But then we used that to launch the brand as it is now, which is all about protection and just making products that perform really well. That took me to China, where we actually met over 10 years ago, actually. And just, on the floor, on the ground, manufacturing, deep in the factories. I was there about 6 years. And then, long story short, I was fortunate I was able to partially exit mouse, take some winnings, and seed Fyous.
Right. So yeah, Fyous. So what's that all about then?
So Fyous is a dream, a concept that I had many years ago. As we both know, making molds, tooling is really expensive. Yeah. It's very time consuming. So with my old business, like Mouse, we were making, towards the end, like hundreds of molds, right, a year. And because you would be racing against time to meet or deliver the cases before the phones had even launched, right? Yeah. And let's say you made all these molds, you made 100,000 units in preparation for the new iPhone launching, and then you found out that a button's been moved. Right. And you're like, oh crap. Yeah. Got to change the tool. Like, how fast can we change the tooling? So it started to make me think, imagine if that futuristic concept of shape-shifting molds, shape-shifting material actually existed, and took me to the idea of using pins, which comes from the toy, the kids' toy, right?
Yeah, the one where you put your face in it.
The very simple concept of that, but how do you actually make that commercially viable, that it can have a lot of design freedom, you can make parts you actually want to make. And so we started upon that journey of what we call polymorphic moulding, which is poly means many, and morphic means changing shape. So yeah, it's a shape-shifting molding solution. Yeah. Okay. So like a dynamic injection molding machine.
And it can be used for injection molding.
Yeah. Well, so that's the one of the, I guess, applications in the future we'd love to try, but it'd be very expensive right now. Yeah. So we're starting at the beginning, which is low pressure molding. Right. So this latest machine that we're building is going to do polyurethane injection. Okay. So it's low pressure, so bit more imaginable. Yeah. And so we've proven that concept, like we can shapeshift these molds in a matter of minutes, inject polyurethane, and produce parts, so dramatically reducing production times. And starting to take that, I guess, fill the gap, because you've got 3D printing where you might be able to do 10 parts before you start thinking about, how can we make this cheaper? And in between that and injection molding, where it's like massive upfront cost. Yeah, we're trying to fill that gap. If you want 1,000 of something,
then this is
the tech. Yeah.
I mean, it's so rare to see a really genuinely new thing. Like most new products are just like an update of something else, but this really does seem like it's kind of come out of
we know. Do you know where it came from? Or the actual, I guess, having the cojones to actually do it was I read the book 0 to 1.
Right. Yeah. Okay.
By
Peter Thiel.
Peter Thiel.
Yeah.
And he talks about don't compete, make new categories.
Yeah.
Be the new Google and stuff.
Okay.
And obviously, it takes a lot of money to do that.
Yeah.
We gave it a good shot.
Yeah. Well, no, I mean it's fantastic. Yeah, and from the looks of things, it's. I mean, you've done it.
Yeah, we're getting there. Yeah. And we've done phase 1. Yeah. So
what were some of the kind of technical challenges that you had to overcome, and how difficult was it, and how important was prototyping to the whole thing?
I guess the first one was like, if you've been in this manufacturing industry, engineering industry a long time now, if you said to an expert in the field, like, I'm going to have loads of these tiny pins that's going to create geometry.
Yeah.
Like, they're all electronically controlled, right? And we've got in the sort of tooling or molds that you see at the moment on the website and stuff, that area is 28,000 pins.
Right.
Like, it's just incomprehensible when you look at like 28,000.
Yeah.
So it's like, how do you actuate them? And I guess number one, are they strong enough to withstand the kind of forces needed for molding, for vacuum forming? And probably most experts would be like, no. Yeah. So the first one was kind of proving it right to ourselves. Like, could it actually be done? Like, and that very first test that I did, that was like, oh crap, this might actually work.
Right.
But it needed that. You needed to spend the money.
Yeah, to do
it. It needed just to be an experiment. So it was an expensive experiment.
Yeah.
But it was the first stepping stone to, could this be a reality? So that was the first kind of moat to get over. And then once we'd done that, it was like, right, where's the commercial viability here? Because interestingly, pin matrix tooling, pin array molding, adaptive tooling has actually been around. I think the first patent we found was 1852.
Right. Unbelievable. Yeah. Crazy. Yeah.
So I guess it was, how do you... Lots of people have tried to do this and failed. Why?
Yeah.
And it's because they've never found a commercial application to make it worthy investing in.
Yeah.
And that's been the next greatest challenge for the last few years is, we can see the vision of this could be used in injection molding, but that's going to take millions and millions.
Lots of investment.
We're not going to get to that point unless we show commercial viability early on.
So how have you gone about doing that? And like, what was the...
So I think we did some wrong stuff and some right stuff. In the beginning, it was footwear. Like, where do you need to change the shape of stuff and make one-off things a lot?
Yeah.
And anything to do with the human body, right? So footwear, like custom fit footwear. So our original vision was a custom fit or affordable custom fit future.
Right.
So anyone could go and scan their feet, and with polymorphic moulding, we'd be able to very affordably make footwear versus like 3D printing, where it's just too expensive still, it's too slow.
Yeah.
Saying that, a little shout out to Viva Barefoot. They're tackling this problem as well. And I think they might actually crack it.
Right.
But like I say, it took like significant amount of investment, and they've already got a brand.
Yeah.
Anyway, so we tried to do that first, but we tried to be a shoe brand, a new technology creator. It's just too much of a challenge, really.
Yeah.
And then actually, no, what killed it was we were making this footwear. So we'd cracked making the footwear, we'd cracked the 3D scanning, and we'd make footwear fit perfectly. And we found that you'd put it on people's feet and you'd be like, mathematically, that shoe fits you perfectly. But they go, no, it doesn't fit.
Yeah.
Because it's subjective.
Right, yeah.
What's tight and loose to someone is different,
exactly,
right?
Yeah, nightmare. Okay, and how do the actual products themselves like stack up against like things that come from a more traditional molding process? Like, are they aesthetically, are they exactly the same, or can you see all the pins on the surface? Like,
so that was actually the next challenge, is like design freedom and the actual outputted part. We didn't have long enough to refine the technology so much so that you had this ultimate design freedom and perfect surface texture, right? We just run out of money. So it's like, what product can we find that sits within the limitations of the tech as it is now? Because it's the worst it's ever going to be now, right? Every month it's the worst. You know, you just keep getting better. So right now you do get like a surface texture. It's like a golf ball type, a bit less than a golf ball type texture. So that's where we fell into the orthotics space, the orthotics manufacturing, which is like insoles and medical devices for the fit for the body, because the surface texture didn't matter as much. It didn't need to be like class A surfaces. But interestingly, recently, and we're just about to file a patent on this, we've come up with a way to massively improve that surface texture and tolerance, which is quite exciting, because it was one of the limiting factors. Like people would always say, well, yeah, but a lot of people are going to want much better surface quality. So that was a challenge, but I think we might have cracked it now, which is pretty exciting.
Yeah, that is exciting. And in terms of the pins themselves, are they all made from the same material?
We've got a special alloy. Right.
Because I think you say it's like never ending.
What do you mean?
Like you can use it forever, essentially. Like
In theory, in theory, you should be able to.
And it's minutes to change the shape of
minutes. So in theory, like over the area, like a shoebox area, of pins. So at the moment, our current one we've got is 0.8 millimeter diameter. Right. So in theory, that 28,000 pins we could form in 2 minutes. It's just a machine being more expensive. So we're trying to find a balance of what people are willing to pay for the machine and the time.
How long they can wait. I mean, I think 2 minutes is very, very fast.
It'd be crazy. It just depends on the application. There might be an application out there that suits it, but the machine might cost £500,000, you see. So at the moment we're finding that balance of time versus cost. So at the moment it takes 20 minutes, but the machine costs £150,000.
Which seems a bit more realistic.
Competitive. Hopefully competitive.
And like you say, that's already a lot quicker than even 3D printing. Which, I mean, advertises itself on the fact that it's faster.
And that's the thing, it takes 20 minutes to create one, but then to create another one just takes the injection time, which is like 3 minutes.
3 minutes, exactly.
So essentially you could have 2,000 parts in 2 days. I think, 1,000 parts in 2 days if you ran it continuously.
Which is, I mean, very, very quick.
So it starts to fill that gap, like where automotive, you know, when you want to just iterate things all the time,
very, very quickly,
rather than committing to tooling.
Changes. I mean, I can see lots and lots of uses for it. I mean, what have you had a lot of interest from industries, from companies? Like,
I mean, so our strategy in the end was footwear wasn't going to work. It was too much of a harder problem to solve. So we pivoted to selling the tech. So we made our first machine, which is kind of generic. It was just to show what could be done. And that's the machine you see on the website right now. And then we sort of opened it up to the world. We went to Formnext.
Formnext.
In Germany. And it was great. Like, it was a bit of a milestone for me, because I was like, finally got this out there. People can see it. And loads of applications came out of the woodwork. An interesting one was work holding. So actually holding complex parts for post-processing. So, you know, with metal 3D printing, you guys do metal 3D printing. But most of the time you need to post-process it or remove the support. So it's like, how do you hold that? And so we started using it for work holding and trying to come up with a concept there. And like aerospace found that really interesting for like all the machining they do. So later down the line, we'll release a product in that space. But orthotics is our first focus, because this is the moulding machine, which could have lots of applications as well. And you get the recurring revenue model. Because the material, because it's our material.
And what challenges have you had to kind of overcome trying to do this in the UK?
Pluses and minuses, actually. So if I'm going to be nice to the UK, Innovate UK have given us a lot of support.
Right.
And it was one of the reasons I wanted to come back to the UK and do it, because
Yeah.
I thought the UK would support, like UK government would support it.
Would support it.
Yeah.
And they have done.
Yeah. So that's been good.
Yeah.
But then venture capital here is just terrible.
Right.
Compared to like the US.
Right. Yeah.
Like for big, bold ideas,
Uh-huh.
it's terrible.
Right.
So that's been really, really tough.
Yeah.
I think if we'd been in America, we could have funded this with seed investments of 20, 30 million.
Right. And has that not made you think maybe you should move over
In
there?
hindsight,
in
hindsight, yeah.
It's never too late.
It isn't too late. And to be honest, I'm planning a bit of a trip over there. So if anyone's watching this. Yeah. It's just a real shame, I think, actually. Like,
It is, yeah. I think, unfortunately, in this country, it just doesn't exist, does it, as a thing?
I
Like,
think it's a
people-
cultural problem, yeah.
I mean, people, when they've got a bit of spare cash over here, they're not investing it in startups, and they're just buying
Doing my best
houses.
to try and do that, though. Have you heard of the EIS scheme?
Yeah, EIS.
So that is one thing that the UK government's done really well on that. Like, Mouse wouldn't exist without
Without that,
EIS,
right,
and
yeah.
Fyous wouldn't exist.
Yeah,
So we've managed to raise like millions through angels,
right.
but it's this
Still
hardware
compared
is so
to-
expensive.
Yeah.
So
I mean, is it the same, do you think, for software and fintech? Is the money available for that? Is it just
I
hardware?
think it is there
Yeah.
because the speed to traction and the I guess how quickly you can attack a market is more proven.
Yeah.
And it's less risky in a way.
It's like with hardware, the wait time's a lot longer, isn't it? Yeah.
Exactly, yeah. And you need the massive amounts of money to scale it as fast as you could scale a software business. But have you ever heard of Hadrian?
No.
You should check that out.
Right.
So Hadrian in the US, it's an Aussie guy actually who went over to the US. He's probably smarter than me.
Right.
He realised that's where the money is.
Yeah.
Went to the US, and it's really simple what he's doing. The problem is you've got a fragmented industry over there of sort of mum and pop machine shops, manufacturers doing all this aerospace stuff.
Yeah.
But it's all mum and pop stuff. It's not efficient. It's
Yeah,
fragmented. So he's just gone and said to VCs, I want to automate all this. Right. Make it really software driven.
Yeah.
And reduce the costs. And he's managed to raise I think he raised 180 million.
Right.
He's only 4 years old. So the company's only 4 years old. And they're building massive factories now.
Yeah.
Like, God.
Yeah. I think
We've got no chance.
The money over there is just like crazy, isn't it? Yeah. Oh well. But at least we're doing some things. Okay,
We're trying.
In this country. Yeah. Thanks to you, we've got companies that are like coming up with innovative products and stuff. So, I mean, you're quite heavily linked with China as well. Have you been using China for manufacturing the parts for
not
for
with
the
this,
products?
no. We've brought everything in-house, yeah.
Right, everything in-house.
Yeah, so we've got our own CNC machines, laser cutters, lathes, because I knew this was going to be IP heavy.
Right.
But also iteration speed.
Yeah.
So if you've got those machines in-house, it's much faster to obviously like solve problems.
Yeah.
But you need the skills.
Yeah, you need the skills and stuff.
Saying that, we've used HLH in the early days to get us off the ground to do some bits. But then, like say, it's the IP side of stuff.
Is that what the main worry was?
I'd say iteration.
Right.
Like I think we trust companies like HLH. They're not going to run away with your ideas.
Yeah.
But yeah, I think it's just iteration, and then eventually investors start saying, well, if you're making this, in China, how are you going to keep the IP safe and stuff? So,
and have you had any issues with that, like with your previous company?
Actually, no. Yeah, and it's funny. Someone asked me this the other day because, like, Mouse, for example, phone cases is the most copyable thing in the world.
Yeah.
I was like, I wonder why we didn't get copied like straight away.
Yeah.
And I actually think it's because I was living there, and the factory owners were like my best friends.
Yeah.
Like the sales girls, like we were always like hanging out, and going to dinner together. And I just think China's very much relationship based, isn't it? Like contracts kind of mean nothing.
Yeah.
They do value a good handshake and relationship. So it's
that
just
saved you.
It's just a theory. I don't know.
Yeah, no. I think you might be onto something there. Yeah, and I mean, obviously, at the minute, there's quite a lot of with the tariffs and anti-China sentiment, which has always been there, really, but it's heightened a little bit at the minute. Like, do you see any opportunities coming out of that for you and your technology?
Yeah, I mean, I guess it's starting to be drawn into my investment pitches.
Right.
Our machine enables localized production, right?
Yeah.
So how do you defend against all this geopolitics and uncertainty? Well, people are talking about onshoring and localizing manufacturing, and that's what our machine enables.
Yeah.
Sorry.
No. I mean, it is what it is, isn't it? Yeah. And do you see the whole thing like as a good thing for the UK manufacturing industry?
Our thing, or just in general?
Both. So like your technology, and then combine that with the fact that we've got massive tariffs on products from China, and
so I think altruistically, is that a word?
It is, yeah.
I wanted to do it in the UK because I do like our country. I moan about it a lot, but I think I'm really proud of our engineering skills. And I'd love to build something that creates a lot of jobs. Yeah. Build a great culture, great company, something that is maybe sits in history as like this was invented here. Yeah, that'd be cool, right? Yeah. So I want that for our company, our country. And then I think with the geopolitics, it could play in our favour. Like for the UK, people start looking to manufacture stuff in the UK because of tariffs, uncertainty. It's interesting, like, I think even though it takes such a long time to bring those skills back, and I think business leaders are thinking, well, yeah, I'm not going to spend 10 years bringing factories back and skills back because new prime minister comes in and it all changes again, right? Yeah. But I think it is changing the mindset a little bit. You're having to think about it. You're having to question your choices now. So even though practically it seems impossible, I think it is changing the mindsets a little bit, which could be good for us. Yeah.
And you've chosen to do a lot of the development and the manufacturing here. Like, how difficult did you find it to get people with the skills and the know-how?
Oh, it's impossible. Right. I mean, just getting people to make stuff. Yeah. That's why as soon as I could, we bought a CNC machine. Yeah. Because just trying to get anyone to make something for you, they'd be like 3 weeks lead time. Yeah. You'd be like, well, I'm going to have to go to China now. Yeah. You guys do it in 2 weeks and you ship it halfway across the world. Where if someone down the road is going to take 3-4 weeks and charge me double. So that's a bit frustrating. I think it just shows that there's a lot of demand. Like if you do exist as a machinist,
yeah, if you could do it,
your order book's full.
Yeah. But what? So have you been doing it yourself?
Yeah. Most stuff we do ourselves. Yeah. Especially CNC machining, because one, the skill set. Yeah. And the cost that to outsource it. And we're constantly iterating. That's the problem. We're not just making 10 off one thing. Yeah. Like we make one thing, we try it. Yeah. It doesn't work. We want to improve it, make it again. And like our JR, one of our guys, absolute genius on the CNC machine. He can just turn stuff around in hours. Yeah. So it's Yeah.
And how many individual components are there in your machine? Like bespoke stuff. Yeah.
I mean, we try and keep it to a minimum. It's the bespoke stuff's all around where our IP sits. Yeah. That's, it's like our little black box. The framework and stuff like that. It's kind of generic machine components. So to be honest, mate, I don't have an exact answer.
Yeah. A lot?
I wouldn't say a crazy amount. Right. I mean, obviously, when you've got 28,000 pins to actuate, you can imagine there's a few bits going on. I think the reason we've been able to make it commercially viable is that with the solution we came up with was really simple for actuating all these pins.
Yeah. And the software side of things, like you've taken care of that yourselves as well,
yeah.
And how easy is that to use for the customer?
Oh, really easy. Yes. It's just like you basically have an equivalent of a slicer.
Right.
So you take your 3D model, you put it in what what we call Pinpoint, which is our software. It's like it's not a slicer, but it acts like the slicer. As a 3D printer. It projects points on the surface,
right?
And then just tells the pins where to go.
Okay.
Yeah.
So you really don't need to be clued up about.
Not at all. Yeah.
No,
I'd say it's even simpler than a slicer,
right?
Because you've not got all the settings.
Yeah.
And then with our molding machine, so you've got that process where it tells all the pins to go.
Yeah.
And then you've got injection parameters, but that's all just set.
Yeah.
Yeah.
Yeah. Could you take your mold and use it on another molding machine? Or?
No, we'd have to. So that'd be one of our next products in the future is a dynamic injection molding machine.
Right.
We'd have to build it all to work together.
Yeah.
So because we use because obviously the pins are liquid will go in between the pins, right?
Yeah.
So we use a membrane that goes over the top of the pins to essentially make it watertight.
Okay, yeah.
So there's some complexity around that.
Yeah. All right. Okay. Yeah. Okay. And I mean, obviously, you've been out to China quite a lot. You used to live there. Now you've come back here to the UK. What lessons do you think UK manufacturers could learn from Chinese manufacturers?
Oof. I think the thing that China's got, and you'll know this, the work ethic.
Yeah. I mean, yeah, that's difficult to.
That's
generations.
It's
but it hasn't disappeared completely. But I think that's.
I think it's just a consequence of developing nations, right? I think you're going to see it in China now. The richer people get.
Well, you already are seeing, like, having a business out there. You already are seeing, like, the younger people are demanding more from the employer in terms of perks and time off and work-life balance and things like that. Than
it just goes in cycles. The more developed a nation, the more affluent, the more options they have. So. So it's going to eventually end up like here. But I do think they do have a slight edge on like work ethic.
Definitely.
So that means the speed of stuff goes fast.
Yeah. But I think like the United States, for all of its kind of similarities with here, they seem to have much more of a
work ethic
than we do.
Yeah. Well, they don't even have like bank holidays. They have like eight holidays a year or something.
Yeah, I think
they
they don't get a lot of holidays. They work really long hours. So how have they managed to do it? Because obviously that's like the most affluent place on earth. Essentially. So.
Ultimate capitalism, bro.
Yeah, I guess. And the lack of a safety net. I think.
Yeah, that's a good point. Yeah, a bit more scary, isn't it?
Yeah.
In China, like I don't know actually what the social system is like there, but to employ people out there, it's fun. All my friends would say, like slave labor and stuff. I'm like, mate, it's nothing like that.
Yeah, it's not at
all.
Like
there's so many rules to follow.
Yeah, there are.
Employing people out there, and I would say that. Engineers, if they're good engineers, they get paid more than UK engineers.
Oh, yeah. The wages over there nowadays are not what they were, are they? Yeah.
But lessons, like, I think the work ethic goes a long way. I'm not sure.
Do you think the UK can reindustrialise? Do you think we can bring back manufacturing? I mean, I guess you're hoping we can.
I think
to a certain extent.
We're not going to bring making cheap products back.
cheap products are...
I think it's not reasonable to think that's going to happen. I think we're just going to end up more and more high-tech stuff, isn't it? Yeah. Defence, I think defence spending is going to go what is already going up, isn't it?
Yeah.
So that's probably where we'll capitalise. Like if people are no longer relying on the US to defend them,
they're going to
and that's why we do really well in defence spending and defence equipment, which is not a good thing. But
and you've been looking at that as well. You said you were looking at the work holdings for
work holding and stuff, but like body armour, custom body armour, right?
Yeah.
So really affordable custom body armour is definitely something that I want to look into in the future, because I think we're going to probably have a principle of like, I don't want to make anything that kills someone.
No.
but I could make something that saves someone's life.
Saves someone's life.
Yeah,
That's different. Yeah.
Take the Lego mentality. Make no.
Yeah.
They don't make anything to do with war.
Right.
Lego.
Do they not?
Yeah.
What about like pirate ships and things like that?
Oh, that's a good point.
Like Star Wars.
Yeah, that's a good point. Yeah. But apparently they don't do any tanks
and stuff. Yeah, okay. They don't
any
do
modern
those.
warfare.
Yeah, modern warfare. Like real warfare. They don't do. Yeah. Okay. All right. Fair enough.
Good point.
Yeah. And what about AI? Like, how's that playing? Yeah, with you guys.
Yeah.
Is that something you're looking at?
I think a lot about that
integrating into
actually. I mean, we're definitely going to integrate it because there's things like how we could use it to optimize mold production.
Yeah.
So how quickly, can you actuate certain pins or not actuate certain pins to get the geometry output? So like efficiency wise, you can start to train your model to learn. And I think AI is the way it's going to affect us the most is the ability to generate CAD, to generate 3D models with no skill. And then people are going to want more of our types of products. They're going to want to make more things and find affordable ways.
Bespoke.
Yeah. So if you can very quickly scan someone's arm and it instantly generate you a 3D model, then you're like, because that's a big part of the cost, isn't it?
Yeah, exactly.
Actually generating the CAD. So I think that's where it's going to impact us the most, and like we'll build software to do that. So it's like a full solution.
Okay, yeah. So you see it as ultimately like a good thing for your business.
Yeah, absolutely. Yeah.
You're not worried about it.
No. I mean, it's already like making a huge difference.
Is it? In what way?
Just software creation.
Just software, yeah.
Like, I'm like a really bad programmer.
Right.
But with AI, I've become a really good programmer.
Right.
So that's just saved me having to hire someone.
Yeah.
And the same with our engineers. Like, we've already really got one software engineer, but he's now 4 software engineers.
He can do the work of 4 people. Yeah.
So it's quite exciting in that sense.
Okay. And what have you got any advice or tips for other companies looking to make hardware in the UK, hardware stuff? Go to America.
Go to America. Don't do it.
Yeah. Other than that.
I think find product market fit first.
Yeah.
Before you find your problem, first.
Yeah.
I think that's one mistake I made, is that I knew the problem was there around changing molds and adapting and making them. It's expensive, but solving that problem was huge. You need millions and millions and millions and millions to do it. So maybe I could have just gone straight to the US and been like, find people that understand the problem. Yeah. Because that's the hardest thing, finding people that understand the problem as well, to get to invest in it. Because unfortunately in the UK, most people that have money are from finance. Yeah. So they just don't. They've never seen a thing. They don't even know what a mold is. You'd be surprised how many people know what a mold is. But yeah, I think find that problem statement, that very clear problem statement first before you start trying to tackle the hardware problem. So for us, eventually we found the very clear problem statement in this orthotics industry, where it was creating do you know what a shoe last is? I know what a last is. Yes. Yeah. So 10% of the world is diabetic, and eventually their condition gets so bad they need custom fit footwear. Right. And to make that, you need a custom last. To make a last, you use CNC machining, which generates loads of waste. It's like 84% waste because you start with a block and you cut it down, right? So you've got all these orthotics companies around the world and in the UK making it for the NHS. So it was like, well, hold on a minute. They're cutting it. They're using subtractive method, loads of waste, loads of time. If we just molded that, the cost reductions are crazy. The waste reduction is crazy. So eventually, finding that problem statement, and then we've adapted our tech to solve it. So you were molding the last, or you were molding the last? Yeah. Okay. And then they build the shoe around it. Right. So we've taken, in some senses, we've reduced costs by 5x. Just because as you know, molding something is so much cheaper. It's just creating the mold was expensive. Now it's really cheap. So going back to your question, just find that problem statement, very clear problem statement, so then you can create the solution for it. Then go build the team and raise the money.
Yeah. Okay. And what's the future look like for Fyous?
So at the moment, we've got our first big customer. It's this medical company making this footwear. So that was huge for us. So we're building the first moulding machine dedicated to like last production for them. And then we're just trying to scale that same product to other companies. Because there's more of these companies doing this.
I mean, there's a lot of companies that need lasts as well outside of that.
Yeah, exactly. Yeah, I mean, the footwear industry in general.
I know one.
Huge.
Oh,
dear. Okay, well, there you go.
Later.
Gonna get a sale here. And then we're raising money to scale that. So trying to raise 2 million quid at the moment. So I'm going to try and convince James after this, everyone. This has all been a sales pitch. So raising 2 million quid and then going to scale, hopefully internationally, selling the products, and then also looking for new applications like the work holding, develop a product for that as well.
Okay. And where should we go if we want to find more information about you guys and what you're up to?
So you can go to our website, which is fyous.com. That's Fyous. Not Fyous, Fyous. LinkedIn is a good one. Like we post some good stuff on LinkedIn. Fyous again on LinkedIn. And probably your best sources,
Okay. All right.
Yeah.
Thank you very much, Josh.
Yeah, thank you, mate.
Yeah, nice to talk to you. All right. Yeah. Cheers. Whether you're working on your first product or your 10th, you've got the Prototype and See podcast to back you up through your product development journey. Follow, subscribe, and tune in for our next episode. We can't wait to see where your prototype takes you.